Welcome back, Contemporary Math. We are in Chapter 2A. And this chapter is titled Understand, Solve, and Explain. And so the book gives you this three-step problem solving that they call USE or whatever they call it. USE, understand, solve, and explain. So understand the problem, solve the problem, and then explain your results. So this is a section where we're going to do a little bit of problem solving, and we're going to start on this thing called unit analysis. And so what unit analysis is, if we look at units, the units would be the feet there, or they are the thing there that describes what a quantity is measuring. So we have some number and we have some sort of word or abbreviation after it. The word or abbreviation would be the units that we're talking about. So unit analysis, that is going to be the process of working with units. So we're going to talk about, well, not in this section. I forgot, they reordered the sections a little bit. I had to reorder my notes. So next time we will be talking about the US standard and metric measurements. In this section, we're going to start talking a little bit about the vocabulary and do a few examples of problem solving. So I went through unit analysis. Per is division, so like miles per hour. So if I talk about miles per hour, that's literally miles divided by hours. So if I'm going like 70 miles per hour, I'm going 70 miles for every 1 hour. Or feet per second. That's literally feet divided by second. Okay. And the next thing I want to talk about is this word of. So if you see the word of, like 40% of 80, this means multiplication. So if I want to do 40% of 80, first thing I really want to do is convert my percentage to a decimal. So 40% would be 0.40. I'm going to multiply that by 80. And what's that giving me? 30, 32? Yeah. Should give me 32. Okay. So understand, solve, and explain. So understand, basically what they mean is to sort of read the problem. To solve, they mean to like set up the equation, define your variables, all the good math stuff. And then when you're done doing all the good math stuff, don't forget we are still answering a word problem. Come back and explain what is going on. Like talk to me like you're talking to your boss or something. Don't just tell him x equals 5. You tell your boss x equals 5 when he asks you a question, he's probably going to look at you a little weird. So we need to respond to these things with words usually. What is the total distance traveled if I run across a 120 meter long soccer field 4 times? So do we understand what's going on here? We're running back and forth 4 times. So if we're doing 120 meters 4 times, this is telling me to do 4 times 120, which is going to give me 480. And if you did this, you understand you solved, but you didn't do any sort of explaining. So the least you can do is throw the word meters on there. Okay. So how many cases would be needed to hold your movie collection that consists of 2103 DVDs if each DVD holds 150 DVDs? I said that word. Each case holds 150 DVDs. So do we understand what's happening here? This is probably like getting to be an obsolete problem now. Not a whole lot of people are collecting DVDs, I don't think. And there's too many streaming services. But maybe you have a DVD collection you don't want to get rid of. So you have 2103, and you want to put it into cases that hold 150. So you're dividing these DVDs into these cases. So I'm hoping you realize like this is going to be something that involves division. So we're going to do 2103, and we're going to divide it by 150. And if we get this, you can do it by hand or by calculator. I don't really care too much. But this is going to give me like 14.02. And so what we've done is we have done the step 1 of understanding. We've done step 2 of, what do they call it, solving. And then step 3, now we need to think about what we just did. This is telling me I'm going to need 14.02 cases to put these DVDs into. And so if I'm just shopping and I'm going along and I want to get enough cases for my DVDs, how many cases do I have to get? I would have to round this up to 15 cases. And normally you wouldn't round something like this up, right? But since this is in a context of this problem, we're going to have 0.02 DVDs left over. Or we're going to have 0.02, not DVDs, cases. I don't know what that would be. 0.02 of 150, I think is what we're doing. How many DVDs is that? I think we have 3 DVDs left over if we only got 14 cases, is what it amounts to. It would be your remainder. I had to go back solve that right quick, sorry. But we have to round this thing up because we don't want to have those 3 DVDs just sitting there. Okay, so this is a quick review. What does square feet mean? What is cubic inches? So a square foot, well, if we go single foot, we go like 1 foot this direction, and we go like 1 foot this direction. And then we square this thing off. This is a square foot. And so maybe starting with single dimension of 1 foot. So single dimension of 1 foot will be things that measure like length. Single dimension measurements, like perimeter would be the length around an object. And then we have something like this, which is a square foot. This measures how much area something is. So it's how many little these square feet we can shove into something. And the other thing we talk about is a cubic inch. Let's see if I can do this right. Does this look approximately cubic, hopefully? It's not too bad. So this is by hand. It's not going to be great. They're the best. But this is 1 inch, 1 inch, and then this guy right here is 1 inch. So we're going 1 inch by 1 inch by 1 inch to make this a little cube. And so this would be something like a volume measurement. So like the measurements we typically use these for are like length, area, and volume. So we've talked briefly about that when we talked about geometry. And there were a few calculations I said we'll get a little more into depth in. And we will do so in this section. The other thing that is a vocabulary store thing is the hyphen. So if I'm looking at a hyphen, and there's 2 sorts of things I can think of. Well, not off the top of my head, it's in here in my notes, but the first thing is something like a kilowatt hour. And if you know what this is, or if you have to pay an electric bill, you've probably seen this word. And so this is something they use to measure electricity. And so if we want to do a kilowatt hour, that literally represents like 1 kilowatt times 1 hour would be 1 kilowatt hour. So it is a multiplication that we're doing in there. And I should really stray away from using X. The other thing to think about is a light year is a measurement of distance. It's the speed of light. I messed that up. Speed of light times what? 1 year. This is supposed to say speed of. I kind of tried to cram it in here. Sorry, it's not too legible. For light year, we just take the speed of light and we multiply it by a year. That gives us a distance. So next, we want to identify the units in each answer. And that we want to identify the units of the answer in each of the following cases. So the price you paid for electricity found by dividing the total cost in dollars by the number of kilowatt hours you consumed. Let me try to focus this a little better. That looks a little better. So we're going to take the cost in dollars and we're going to divide it by the kilowatt hours we consumed. So there's a few ways you can write this thing out. One of the ways is you have dollars and you're dividing it so you could say the word per. And we're dividing it by kilowatt hours. You do dollar sign, you can divide it by kilowatt hours. If you want to do complete symbols, I guess. Kilowatt hours, HR. So if you're doing like 13 cents per kilowatt hour, it would look something like that, maybe. Or you could just write these words after that number, right? There's a few different ways you can write it. And there's a few correct, there's a few incorrect, I guess, right? The area of a circle found with the formula pi r squared, where the radius r is measured in yards. So if we're measuring our radius in yards, our length measurement is in yards. So think about our length measurement. What is our area measurement going to be in? And so our area measurement is going to be in square yards. So you can write out the word square yards. Or you could do the yards with the square sign. A volume found by multiplying an area measured in acres by a depth measured in feet. So this is a weird thing, and I don't expect anybody to know this off the top of their head unless they're doing hydrologist, I think, are the people that do this. Yeah, that's what I have here in my notes. A hydrologist is a water engineer. So if you know a hydrologist or someone that studies land, they might know this, but it's acres by feet. Okay. So I'm going to do a brief sort of review of fractions. So if I have a whole number like 4, if I want to write this over something, I can write it as like 4 over 1. If I have something that's a negative, like minus 3/4, that's the same as if there's like one negative on top and a positive on bottom is going to make that overall negative. And it's the same if I have a positive on top and a negative on bottom. So typically we write it probably one of these two ways. But this is also correct. And so I could put a negative on top, I can put a negative on bottom. Then you might ask, what happens if I put a negative on top and on bottom? Well, if I do that, it's going to be positive. So it's kind of silly. I could have done it, but I could write that as a -4 over a -1 if I really wanted to. You're probably never going to see me write that. So I want to talk about adding and subtracting. So there's two sorts of ways if it's set up really nicely. So if we have like 2/7 and we're going to add another 4/7. The process is we keep the denominator. So if the denominator is the same, we keep the same denominator, and we do like 2 plus 4 in the numerator, which will give us what, 6/7. Okay. So then the other question is, what if they are not the same? So if I have something like 2/3 plus 6/5. How do I do this? So the way that I do this is I have to find a least common denominator. So what I'm doing is I'm looking at a multiple between 3 and 5. So I'm thinking about numbers that are multiples. So just a quick recap, that would look like 3, 6, 9, so on. What I'm thinking about is where are these going to cross first, right? And there are no common factors between 3 and 5. So if there's no common factors between the numbers, it's just going to be 1 times the other. That's the best thing. That's sort of the best number that we can get there. So quick recap of how we get a common denominator is we got to make them 15 is the LCM of the denominators is the LCD. So the least common multiple of the denominators is the least common denominator. So if you see LCM or LCD, they're kind of interchangeable here. We're talking about the same thing. So we're looking for 15. We want to make 3 into 15. How do we do that? We have to multiply this thing by 5. And if we do it to the bottom, we're not trying to change this fraction. We're just trying to write it in a different way. We have to multiply the top by 5 as well. Here I'm looking, I want to make this 15. How do I make 5 into 15? I have to multiply this by 3. And if I do it to the bottom, I also have to do it to the top because I'm not trying to change my fraction. I'm just trying to write it in a different way. So this is going to give me 10 over 15. This is going to give me plus, this is going to give me 18 over 15. And now I have a common denominator. Once I have my common denominator, I keep my common denominator, and I add 10 plus 18 on top is going to give me 28. So you keep the common denominator. If it doesn't have one, you're going to have to do some solving to find one. And then you're going to add these things across. If it's subtraction, you'll subtract that number. I'm not going to spend a whole lot of extra time doing that. If it's subtraction, you subtract it. So 5/7 minus 3/7. I don't want to find a common denominator again. This is going to give you 2/7. So if it's subtraction, subtract it. Multiplying. So multiplying is probably the easier one, to be honest. This one, we're going to have to find common denominators and do a lot of work. Multiplying, if we have something like 2/3 times 3/8. So if I'm going to do 2/3 times 3/8, what I'm doing is 2 times 3 on top, and I'm doing 3 times 8 on bottom. Okay. So this is 6 over 24. I'm going to have to reduce it now. So if I divide both top and bottom by 6, I should get a quarter. So this is one way to do this multiplication. This is probably not the way I would do it. So I forgot to talk about that principle earlier. So let's talk about a certain sort of like principle about some stupid ways to write the number 1. So if I talk about the number 1, I could do 9 divided by 9 is going to give me 1. What, 10 divided by 10? Whatever number you want to pick, right? I can write any number over itself. It's going to be 1. And we're not going to talk about 0. We're going to pretend like 0 is not existing right now. But any number that's not 0, I can do this with, right? Any real number out there should be true. Besides 0. If I do x over x, that should also give me 1. So anything over itself should be 1. There's going to be something similar when we get to our units and you get to talking about our units. If we have sort of like feet over feet. We will be able to simplify out these units, so to speak. Okay, so I want to go back to this multiplication problem after I just talked about how to write 1. So you might notice when we multiply things across, everything on top is just staying on top, everything on bottom is just staying on bottom. Here you might notice I have like a 3 over a 3 and have like a 2 over an 8. So I'm going to rewrite this here and I'm going to rework this problem, but I'm going to use like a sort of shortcut, and this is the way that I'm usually going to work my fractions. So one way you can simplify fractions is you look across. So if I'm looking here between 2 and 8, I can take out 2 from each one of these things. So this is going to leave me with 1. This is going to leave me with, if I divide 8 by 2, it's going to leave me with 4. Here I'm looking across, I can divide 3 by 3, and I can divide 3 by 3. So 3 and 3 can get divided by 3. Now, I'm looking across here. I'm doing 1 times 1 on top is going to give me 1. So be sure to put your 1 when you multiply it through. This is my numerator. My denominator is 1 times 4 is giving me 4. So to me, this is a lot quicker than doing this and then reducing your fraction. 1/4 is fully reduced. We don't have a lot more to sort of do with that thing. And I want to say, like, I did that thing with the feet over the feet. It's okay if it's over itself, but guess what? Even if we have like something like feet and feet there, right? Think about simplifying those things out like that. Okay. So the last sort of thing is about dividing in reciprocals. So this isn't a whole lot different from the multiplication, to be honest. If you want to think about 24 divided by 2. That's an easy thing probably to start out with. I have 24 and I'm dividing it by 2. So that is just something you probably don't want to make more complicated, but let's make it more complicated. So if I'm thinking about this and I want to make these like whole numbers fractions, something you can do is put them over 1. By 2. Dividing by 2 is the same as having something. So having something is the same as multiplying. So let's change this to multiplication as 1/2. And so if I do this, I'm going to end up with 24 over 2, which is going to give me 1/2. So that's probably a lot more complicated than you wanted to do it. You probably just said 24 divided by 2 is 12. But it's going to give us the same result. So dividing by 2 is the same thing as multiplying by 1/2. So how do we go from 2 over 1 to 1 over 2? We flip these numbers. And so flipping the numbers is this thing called a reciprocal. So they have the word right here. So we want to find the reciprocal and multiply. So sometimes people say copy dot flip. They mean find the reciprocal. So if we have something like, let's do another example. I'm running out of room on this paper. Grab my white paper. Go. I'm gonna grab some white paper. And we have 5/7 divided by 2/3. And so if I want to do this, I copy the 5/7, I multiply, and I flip this into what? 3/2 is what it's going to flip to. And so I do 5 times 3 on top is going to give me 15. 7 times 2 on bottom is going to give me 14. So when we multiply numbers, or when we multiply fractions, we multiply straight through, top times top, bottom times bottom. If it's division, copy dot flip, we find the reciprocal and we multiply. Okay, so now we're looking here at conversion factors. So we're doing unit conversions. Convert a length of 270 inches 2 feet. There are 12 inches a conversion factor. I'm starting with 270 inches. This is the thing I'm starting with. I want to end up in feet. And so it might seem really silly because you could probably figure this out without doing all this, but I'm trying to set you up because the world's going to get a little more complicated than transferring inches to feet. We want to be prepared for that. So 270 inches. If I want to, I can always write a whole number over 1. So just it goes on top. If you don't want to write that 1, just like remember the whole numbers are in the numerator, right? And I want to multiply this by a big fancy 1. So what I'm thinking, and maybe I should write it over here, but I'm thinking it's either going to look like this, 1 foot to 12 inches or 12 inches to 1 foot. This is the same thing over itself. So if I multiply by that, I'm not changing this thing. I'm changing the way the fraction looks, but it's just an equivalent fraction sort of thing. We're just multiplying by 1. So I want to set this up so that my inches cancel. And so I want to use a simplification thing like I was showing back when we're doing multiplication. So if I have something here, it should simplify with something over here. So if I have inches on top over here, I want to put inches on bottom over here, and I'm going from inches to feet. And make sure you write the correct numbers in here. There are 12 inches in 1 foot. And so what this is telling me, I can look across here and I can simplify out inches. And I'm going to be left with feet in my numerator, which tells me this is a measurement in feet. So this is giving me 270 on top. It's giving me 12 on bottom. So this is telling me to divide. So a lot of people, they might know we're going from inches to feet. There's this old little rhyme, small to big, divide the pig, big to small, multiply all. So we are going from small to big. We are dividing this thing. So you might know just sort of like in your mind already how this thing goes without setting up this unit analysis where these units simplify out. But like I said, the world gets more complicated. And so we want to be able to keep track of these things. And this is the sort of way it is really going to benefit you to go about this. So if we do this, 270 divided by 12, this is giving me 22.5 feet when I calculate it. Okay, so I think also using sort of context of this thing, you could probably give me like improper fraction or something. But I think when you're asking like convert inches to feet, probably this decimal is probably like the most descriptive, right? When we talk about measurements. Convert a time of 54.60 seconds to minutes. It's the same thing. We want to think about 54.60. You can write this over. And I want to write something that converts seconds to minutes. And so I see the seconds on top. And so the first thing I want to do is get rid of the seconds. So if I get rid of the seconds and want to write it over here, I want to write the seconds on bottom. So if I write seconds on bottom, I have to write the other thing I'm converting to, which is the minutes, on top. And I know there are 60 seconds in 1 minute. Now, if I'm looking along, I want to make sure my units are working out. I want to make sure my units end up on top. Seconds divided by seconds. So my seconds should simplify out. It should give me something in minutes. So this is going to give me 5460 over 60 if I multiply through. So I know you might be able to skip like that step, right? If you're getting this stuff down. And this is going to be 1 minute. But for the most part, you should show most of your work. You should show the setup of the unit analysis and the setup of these fractions. It is really, really, I don't know how else to emphasize it, but it's really going to be beneficial. And so this one might know home how many seconds in a day. So if we have 1 day, and we want to convert 1 day to seconds, my days. So I want to simplify out my days to, I guess I can go to hours. So 1 day is what, 24 hours? And now I'm in hours. I want to simplify out my hours. I can go from hours to minutes. 1 hour is what, 60 minutes? This should simplify out my hours. And the next thing I'm looking at is minutes to seconds. So I want to simplify out my minutes. And so this should simplify out my minutes. And so this should sort of tell you what we're doing. So we're going to have nothing but ones on bottom. So I'm just going to kind of ignore the bottom. We're going to divide by 1 in the end. It's not really going to do anything. But what we're doing is 24 by 60 by 60. And it gives me 86400. 1,400 seconds. So now we're getting back to that thing we talked about in chapter 10. Conversions with units raised powers. So back in chapter 10, I talked about this sort of thing. If I go from like 1 to 3, right, in a single dimension, if I convert that, to a square dimension, this is giving me 1 area. This is giving me an area of 9. So if I triple something in the single dimension, I'm doing it by a factor of 3. I'm doing it by a factor of 3 squared in the second dimension, and so on. If I do a cube of sort of things, 1 by 1 by 1 cube, and I do a 3 by 3 by 3 cube, it's going to be by a factor of 3 to the third. So whatever your factor is, we have to raise it to that exponent. Three by 3 by 3. And we want to see this here. If we go from a yard to feet, that is like going from a factor of 1 to 3. So this is a similar sort of thing. If we know that 1 yard is equal to 3 feet, we can write an equivalent fraction of 1 yard to 3 feet. And so this is like a big sort of fancy 1 here. So if I want to think about single dimension yards, that's going to give me 1 to 3. But if I want to up the ante a little bit, 1 times 1 is going to give me 1, and I have yards times yards. This is now a square yard. That's what a square yard means, right? We're going yards by yards. Same thing here. I'm going 3 by 3 is going to give me 9 feet squared. So my conversion factors are going to be a little different. So 1 yard squared is going to be equal to 9 feet. So we have the same sort of thing happening here. When we're doing second dimension units, we're going to have to square the factor. So 1 yard is going to be 3 feet. 1 yard squared is going to be 9 feet. And you probably can guess from that previous thing, example 1 to 3, if we're going to the third dimension, it's going to be 3 to the third, 27 feet squared. I don't have much room here, but if I were to add another yard here and another 3 feet and multiply this through, these would become cubes, and this would become, can I make a 2 out of this? 27. Squeeze it in there. And so those conversion factors are going to be different depending on what dimension they're in. But we can account for this if we do unit analysis. If we write out what things mean. And so let's look at this next thing. So you want a carpeted room that is 15 feet by 32 feet, which makes it 480 square feet. But the carpet is usually sold by square yard. So how many square yards do you need of carpet do you need? Sorry, excuse me there. So I have a 480 square feet. So if you want to write out 480 square feet, that's fine. But what I really want to do in this problem, I want to really emphasize square feet really means feet times feet. And so I'm starting out with 480 square feet. If you want, you can always write a whole number over 1. And so if I want to convert this, I want to get rid of one of these feet. So I'm going to do it sort of one at a time here. So I want to get rid of a foot. I'll be left with 1 foot. But this will get rid of one of these feet. And so I want to go from feet to square yards. So I'm going to go from feet to yards. So I know there are 3 feet in every 1 yard. I'm going to have to do this one more time to get rid of the other foot. And now I'm not going to have any more feet. So what's happening here is I'm getting rid of this with one of these, and I'm getting rid of this with the other. And so what you might notice is I have 480 times yards on top. So on top, I'm going to have yard squared. I'm going to have 480 on top, and I'm going to have 3 times 3, which is 9 on bottom. So I'm going to have to take 480 and divide it by 9. This I think 53.3. A little room on the paper, but there you go, yard squared. Okay. You're preparing a vegetable garden that is 35 feet by 16 feet, and you need soil to fill it a depth of 2 feet. Landscape Supply tells you soil is sold by the cubic yard. How much soil should you order? So this is I don't know how to say it, but this should be very similar looking to the previous one, but we're upping it a dimension. So I'm going 35 feet. Let me write my units on there. 35 feet. And I'm multiplying it by 16 feet. And I'm multiplying that by 2 feet. And if you want to write it out, this is going to give you some number. Each one of these you could put over 1 if you want to. But we need to cancel out feet to yards 3 times. And so, like I said, it should look very sort of similar. We have feet that we want to get rid of, and we want to go to yards. So we're doing 3 feet for 1 yard. We're doing 3 feet for 1 yard. And we're doing the same thing here. 3 feet for 1 yard. Barely got enough room to squeeze it on there. But there it is. And going back through our units, this is going to simplify out that feet. That's going to be that feet. That's going to be that feet. Sorry, not the 3, just the feet. I'm looking at this. Do I have anything I can simplify out? It's kind of not the prettiest, but if we go 35 by 16 by 2 is what I see on top. Everything else is a 1. I don't really need to worry about it. I'm going to have 1120. My units on here, I guess I should look at those, are going to be yards times yards times yards. I guess I'll write it once. There's going to be a little bit of simplifying I have to do, huh? 1120 yards times yards times yards. I don't have anything on bottom besides 3 times 3 times 3. 3 times 3 is 9 times another 3 should give me 27. Let me double check because that number is not right in my notes. 35 by 16 by 2 is going to give me 1120. And I want to divide by 27. And I'm going to round this to like 2 decimal places. So this is, I should probably do the approximately sign then. 41.48. So usually if you do things correctly and I set up the problem correctly, I think 2 to 3 decimal places, it should usually be pretty good, unless I'm telling you something otherwise. But usually 2 to 3 is pretty good. Okay, not too much more. There's one sort of other thing we want to learn. And the last thing that we have for today's topic, or for this section's topic, is currency conversion. So I know a lot of these conversions you could probably find an app or something, Google, to do something to do these in, which is fair enough. But you're gonna need to learn how to do these by hand for this class. This is pretty much probably what you're gonna have something like this on the test. I'm gonna give you a currency conversion and ask you to convert currencies. So I know Google will probably give you it, but for the homework, for the work in this class, I want you to use the table. And I want you to learn sort of this unit analysis. It will really help you. The other thing is, I know like if you're getting currency exchanged, you also really want to be sort of careful where you do that. Not all places exchange it at the same rate. Some places charge you some hidden fees and stuff like that, from what I've been told. So it's definitely something you want to double check. So we have our rate, we have our table up here. So a little bit about what this table means, and maybe I should write it in. This says dollars per foreign. So this means there are even dollar amount, $1.221. Draw on that sign. Not the rest. You're a sign or something. This means that we have this many American dollars for every one, and I'm going to abbreviate Canadian as CAD. This means we have this many dollars for every 1 euro. And so that's probably enough for you to figure out the rest of this. Dollars per yen, dollars per peso. So if it says dollars per foreign, that's what it means. Now they're talking about the foreign. So let's look at this. If this is euros, what this is, or no, this is pounds. Sorry, pounds for every $1. So the numerator would be pounds. The denominator would be dollar. These numbers do sort of have a relation. So we talked about these sorts of I multiply by 3/4, it's the same thing as like dividing by 4/3, or vice versa. And that's how these numbers sort of relate, is they are reciprocals of each other. And one of the easy ways to do a reciprocal, you 1/3. We don't like to have fractions and fractions. So if you want to flip 3/4, you can always put a number over 1 and it does its reciprocal. And I'm going to show you a little bit maybe here why. We're going to end up multiplying 4/3 top and bottom. 4/3 on top, and this is the number times its reciprocal is 1 on bottom. It is going to give me the reciprocal. So if I want to reciprocate things, doing 1 over reciprocates it. If I do 1/3, it's going to give me 4/3. If I do 1/4, it's going to give me 3/4. So if you want to do like 1 over, it's probably going to be pretty close, but a little off because it's probably rounded itself. But if I do like 1 over, let me clear everything else. I'll do just that on there so you can see that. So if I do 1 over 1.221, I'm going to probably get close to that number on the right. And if I get 1 over, what is it, 0.8191. So these are reciprocals of each other. So if I'm being honest, you could probably black out one side of this thing and just use one side or the other and never have to worry about the other side, just depending on how you set up your equation. You should get pretty close to the same number, probably not exact, but as long as you're in the ballpark and doing your calculations correct, you will get credit for that. But they got to be set up correctly is the main thing. I care more about the process than your result. So if I'm starting out with this again, in this first problem, so you're at a Japanese department store, you see this shirt for 6,400 yen. You want to know how much that is in, US dollars. We go from yens to dollars. And this is 6,400. If you want to, you can always put a whole number over 1. We're going to put that over 1. We want to do something so this yen simplifies out. So if I want the yen to simplify out and it's on top, I got to put it on bottom over here. And if it's on bottom, so now I'm looking at my table. And I think I'm going to go with this one. This is dollars per yen. And you can pick this one or you can pick this one. It's just going to end up either multiplying or dividing. So if we multiply by a really teeny number, or we divide by a large number, right, it should give you the sort of same thing. We're going to take a really small fractional amount of something, or we're going to divide something by really large numbers, kind of saying one and the same thing. So if we do 6,400, and we multiply that by 0.008658, we should get something like 55.4112. And here I think I'm going to round a little bit to the nearest dollar. Probably round down because it's 0.1. Okay, so now we're vacationing in Europe. So in this one, we start out with the foreign dollar amount, then we went to the dollars. Now we're starting out with dollars, and we want to know how many euros we can get from that. So if we're starting out with 150 dollars over 1, we want to cancel out the dollars. Maybe I should have some consistency. If I'm going to do dollars there, I should probably do dollars here. So I want to cancel out dollars with dollars. I'm looking at my euros. I want to go from dollars to euros. There's two different ways I can do this. I'm looking here. I can go from 1.058 and put that on bottom, or the other way I can go is from euros to dollars. So I'm either multiplying by 0.9449, or I'm dividing by that 1.058. Either way, it should give you something pretty close. And we're going from 150 to 141.735. I think they're probably only going to give you 7.3. Ooh, and I put this there. It should not be a dollar sign. Sorry. This should be in euros now. And I put it down, but I hadn't been doing it. We can simplify yens with yens. We can simplify dollars with dollars. I said it, but I probably didn't mark it. So let's go and mark it. And the last thing. Whew. I think we threw out how they rearrange things. But we need to know conversion factor here. So there are 3.785 liters equals 1 gallon. So that's conversion factor that I think we had. We rearranged things and now we didn't have it. But now we have it. So we want, there's a gas station in Canada selling gas for $1.76 per liter. What is the price in dollars per gallon? So this is the last sort of problem we're going to end up with, probably one of the most difficult problems, but we can get through this. We know how to do unit analysis. And you can go around and you can just tell people, I know the skill of unit analysis. So 1.76 Canadian per liter, 1.76 Canadian CAD is how I'm going to abbreviate that for every 1 liter. So the first thing I want to get rid of is this thing that says Canadian. So I'm going from Canadian. And I'm going from Canadian. And I want to figure out what that is in American dollars. So my Canadian dollars, I'm getting 0.7586, 0.7586 dollars for every 1 Canadian. This would give me something if I mark through it. I'm going to get dollars on top. I'm going to get liters on bottom. Now this is probably one of the more challenging things that we're going to do today, but I want to get rid of this liter. So I want to go from liters to gallons. So I have liters here. If I want to get rid of a liter on bottom, this is a little bit backwards from what we've been doing today. So this might be a little more challenging, but I'm going to put it on top. This is on bottom. I want 1 on top, and I want that number 0.785. I want to go from liters to gallons. 3.785 to 1. Okay, so I'm taking 1.76. I'm multiplying it by this fraction. I'm multiplying it by this 3.785. If we notice, this liter and this liter should simplify. I should end up with something that is dollars per gallon now. And what I'm getting is 5.0, and I think I rounded it to the 10th of a cent. Just so we can have that good 3/10 of a gas price, right? It's usually the way you see it on the billboards, 5.05 and 3/10. So it sounds probably kind of cheap that it's 176 Canadian per liter, but that's $5 per gallon of gas. All right, so stick around, check out Tubi, and I will see y'all pretty soon.